Monday, asynchronous learning. We're starting with chapter 12. Today's sections are 12.1 and 12.4. We're talking about prisms. 12.1 is the surface area of prisms, sometimes referred to the area of prisms. 12.4 is the volume of prisms. First off, some vocabulary that we need to get out of the way. Polyhedra are solids. When we say solids, we're talking about three-dimensional objects. So you'll see some polyhedra down here below. Solids with flat faces. Polyhedra means many faces. Polyhedron would be one. Polyhedra are plural. Faces are the flat sides of the polyhedra. So this appears to be what you would call like a box, right? But rectangular prism is a more mathematical, detailed name for it. But the sides of the box you can touch. Those are the faces, the flat parts. The edges are the intersection of two faces. So an edge of a box, right? So where two faces meet, that's the edge of the box. Prism is a polyhedron containing two congruent parallel faces and a set of parallel edges that connect corresponding vertices. So here we have a triangular prism. Let's read that one more time. A prism is a polyhedron containing two congruent parallel faces. So where are the parallel faces of this triangular prism? It's the triangles here, the triangle here on the left and the triangle on the right. So when we hear the word bases, a lot of times we think bottom and top, which is what we see here with the pentagonal prism. The top and the bottom are the pentagons, and there's two of them. They're parallel to each other. With the triangular prism, uh, there are two triangles that are opposite each other and parallel to each other. The rectangular faces here on the triangular prism are not parallel to each other. With a rectangular prism, now this is what's interesting about a rectangular prism is um, the top and the bottom, you could call that a base. The right side and the left side, you could call that a base. The front side and the back side, you could call that a base. So whenever you're working with a rectangular prism, you need to define uh, two sides as a base. And if that's confusing to you, just hang on here. We'll get into some examples. Hopefully it'll make more sense as we move along. But every prism has two bases. They're the parallel faces. And here we are on the bases. So the two parallel and congruent faces of a prism. Here we have a triangular prism, and you can see the bases up top here and down below. Those are the two parallel and congruent faces. The rectangular faces here on this triangular prism, they are not parallel to each other. Also, you'll notice that the name of the figure is, the name of the solid is based off of the bases of the solid. Lateral edges. These are the parallel edges joining the vertices of the bases. So the lateral edges are the parallel edges joining the vertices of the bases. So think about what the lateral faces are. So the lateral faces are the faces that are not the bases, and the lateral edges connect the bases. Okay, so just look over the figure on the right here, and I think that'll hopefully clarify the definition. Lateral faces are the faces of the prism that are not the bases, as we just stated. Lateral surface area is the sum of the areas of the lateral faces. So to find the lateral surface area, you would find the area of these three rectangles, and you would add them up together. Total surface area is the sum of the prism's lateral area, lateral surface area, and the area of its bases. So it's the area of all the faces. So on this triangular prism, let's go back to the triangular prism up top. This triangular prism consists of three rectangles. So you would find the area of those three rectangles. It also consists of two congruent triangular faces. These are called the bases. So you'd find the area of those two triangular faces there. You would add up all those, the area of each face. So you'd be adding up 5 different areas there. Some of the areas obviously are the same, like the triangular faces are the same. And it's possible that the rectangular faces are also the same, but you are adding up 5, the area of 5 faces there. For the pentagonal prism, to find the surface area, it'd be the area of the top, the area of the bottom, and then the area of the lateral faces that we call it the lateral area. So each of these rectangles. So the pentagonal prism has 5 sides around it, 5 lateral faces, and it has 2 bases, one on the top, one on the bottom. So we have a total of 7 faces. We have to find the area for each of those to find the surface area of the pentagonal prism. All right, so that was total surface area. So sum of the prism's lateral area and the area of its bases. Let's talk about volume. Volume is the number of cubic units of space contained by the solid. How do we find the volume of the prism? It is the area of the base, right? B is the area of the base, multiplied by the height, where height is the height of the base. Now, when we talk about height, the height is going to be the perpendicular segment from one base to another. So let's see here. Uh, this pentagonal prism, it would be the perpendicular segment from one base to the other. Sometimes you have a prism like what this one appears to be that is slanted a bit. So this lateral edge would be called what we call the slant height. So what we want is the perpendicular segment from one base to the other. So as we work these problems, a lot of times you're told you have a right triangular prism or a right pentagonal prism. What that means is these lateral edges are perpendicular to the base. So if you have a right triangular prism, these lateral edges, that would be your height. All right, so volume of a prism is the area of the base multiplied by the height. That is that perpendicular segment, not the slant height. The height connects the bases. Here are some types of prisms. We have some polygonal prisms. So here we have a 1, 2, 3, 4, 5. That's a pentagonal prism. Here we have some triangular prisms, rectangular prisms. This is appears to be possibly a cube. Cubes are also rectangular prisms. It's a special kind of rectangular prisms. The way we find the volume of any prism is the area of the base times the height. Well, if you're dealing with a rectangular prism, what is the area of the base? It's length times width. So the volume of that prism would be the length times width times height. And here we see a visual of what the volume of a rectangular prism is. Remember, volume is measured in units cubed. We are multiplying 3 different dimensions, so it's going to be units cubed. And this is a representation of those cubic units making up that rectangular prism there, and the volume of it too. On to example 1. I'm going to reveal these one at a time. So if you're having a hard time with this, just check back and you can see part A and then see part B and then see part C as well. So example 1, the triangular prism shown has base edges of 15, 15, and 18. The height of the prism is 24. So when it says the height, we assume it is that perpendicular segment there. That is enough to know that this is the actual height of this prism, and we don't have to worry about like, oh, I've got to find that perpendicular segment. It is implied by them using the word height here. So the height of the prism is 24. A, find the lateral area. Remember the lateral area, that's the area of all the lateral faces, and the lateral faces are the faces that are not the base. And then part B is going to be find the total surface area. Part C is going to be find the volume. So pause the video now, try example 1 on your own. All right, first off, part A, find the lateral area. So these rectangular faces, those are our lateral faces. This one right here, where the cursor is 24 by 15. On the back side here, remember the height, so all these lateral edges for the height, they're all going to be 24. The height, that's the edge that connects the 2 bases, they're all 24 here. So this backside rectangle, it is also 15 by 24. So 15 times 24 is 360, and we have 2 of those. So 2 times 360 is going to be 720 for those 2 faces. Now this on the bottom side of this figure here is 18 by 24. So 24 times 18 is 432. 2 times 360 plus 432, we get 1,152 units squared for the lateral area. Okay, on to part B, find the total surface area. Well, we found the lateral area. What we need to find now is the area of the bases. Notice that we have an isosceles triangle for our base. So 15, 15, and 18. I can draw in my altitude here, and I end up with this triangle here. Remember, the altitude, the height, is going to bisect that base. So we have 9 for half of the base. We have a hypotenuse of 15, and this is a 3, 4, 5 Pythagorean theorem. 3 times 3 is 9, 4 times 3 is 12, so our height is 12, 5 times 3 is 15. So the area of this triangle is 1/2 times the base, which is 18, times the height, which we just found to be 12. Half of 18 is 9, 9 times 12 is 108. Now remember, we do have 2 of these bases, so 2 times 108, the area of the bases, is 216. So if you recall from part A, the lateral area was 1,152 plus 216 in part B there for the area of the bases, and giving us a total surface area. I should say SA for surface area. Total surface area of 1,368. Okay, on to part C, find the volume. Volume is area of the base times the height. We found the area of the base to be 108. Okay, let me change this to area of the bases. Volume is equal to area of the base times the height, just area of one of the bases. So we found that to be, start part C over. So again, volume is area of the base, just one of the bases. The area of our triangular base here we found to be 108. So B is 108. The height is that perpendicular segment connecting the two bases, which is 24, that was given to us. So 108 times 24, we get 2,592 units cubed for the volume of this figure. So the way you might want to think about volume is it's like one base stacked on another, stacked on another. So a triangle, this 15, 15, 18 triangle, this isosceles triangle, and then one just like it stacked on top of it, and one just like it stacked on top of it. And you do that until you get up to a height of 24. So it's kind of like if you're stacking quarters, right? So like a stack of 10 quarters, the volume of that stack. So imagine I've got 10 quarters here, right? So we got a quarter, okay, and then a quarter on top of it, and a quarter on top of it, and a quarter on top of it, and a quarter on top. I'm gonna stop right there. I think that's 5. 1, 2, 3, 4, 5. Yeah, so this has a height of 5 quarters, right? And the area of the bottom quarter, you know, the radius of these quarters are all the same. So pi r squared, all of these are identical. So its area is the same for each of these quarters. Now, let's say I took my stack of quarters and I tilted it over. So now it's this 3, 4, 5, and I should have done a better job drawing that one. So just think about it logically. If you took a stack of 5 quarters and you tipped it over to the side a little bit, well, the area of the base doesn't change. That's still a quarter. The radius of that bottom quarter did not change. Did the height of the quarters change? No. It's still going to be a height of 5. And therefore, the volume of this did not change. And intuitively, it makes sense, right? So we have the stack of quarters. We hold on to it in our hand. And it's a certain size, and it takes up a certain amount of space, the volume. It doesn't change just because you tip it to the side. So that's something to keep in mind with regard to volume, and thinking about it in terms of like one of these shapes stacked on top of another for the height is another good way to think about it as well. All right, on to example 2. Given the rectangular prism, find the lateral area, the total surface area, and the volume. Now, hang on one second before you go off and work this one. Just so we're all on the same page, we need to make sure we define the base to be the same thing. So you could say the top and the bottom of the base. That would be totally fine. You could say the front and the back are the base. That's totally fine. You could say the right side and the left side are the bases. That would be totally fine as well. Just so we're all on the same page, let's say our bases are the 8 by 10 side on the right and the 8 by 10 side on the left, which means our lateral faces would be these rectangles here in the front and the back and the top and the bottom. So keeping in mind, let's call the base the right side and the left side, the 8 by 10 side and the 8 by 10 side. Find the lateral area, the total surface area, and the volume now. Okay, first off, the lateral area. The front side, I should say the bottom side. The bottom side is going to be 17 by 8. The top side is also 17 by 8. So 2 times 17 by 8, that's going to give us 272. Now the front side and the back side, they're 17 by 10, and the back side is also 17 by 10. So 2 times 17 by 10, that's 340 units squared. You add all that together to get your lateral area, and we get a lateral area of 612 units squared. For the total surface area, we need to now find the area of the bases. So the area of the bases are 8 by 10. So 8 times 10, and there's 2 of them. So 8 times 10 times 2, so that would be 80. Times 2 is 160. So the area of the base is 160. To find the total surface area, it'd be the lateral area, which is 612, plus the area of the base is 160. We add that together and we get 772 units squared for the total surface area. Now onto the volume. Length times width times height for a rectangular prism. 17 times 8 times 10. And that gives us a volume of 1,360 units cubed. Volume is measured in units cubed. Okay, moving on. Example 3, given a cube with edge 15, find the lateral area, the total surface area, the volume. Now, as you look at lateral area, you might think, well, this is a rectangular prism. We need to define which 2 are the base. It doesn't matter in this case because remember, a cube, all the faces are the same. So it doesn't matter what 2 faces you call the base. The lateral area is going to be 4 of these faces added together, and the remaining 2 would be your 2 bases. So it doesn't matter what 2 faces you call the base. Lateral area is going to be the same either way. There you go. Go ahead and work this one out. First off, part A, we have 6 faces, 4 lateral faces. So 15 times 15 multiplied by 4. That's going to give us a lateral area of 900 units squared. For the total surface area, we got to find the area of the bases now. There is 15 by 15, and there's 2 of them. So 15 times 15 times 2. The area of the bases together will be 450. We now add that to the lateral area to find our surface area. So the surface area is 900 plus 450, giving us a total surface area of 1,350 units squared. Finally, the volume, length times width times height for a rectangular prism, which a cube is 15 times 15 times 15. We have a volume of 3,375 units cubed. On to example 4, the last one, shown as a regular hexagonal prism. That means the base is a hexagon. Not only that, it's a regular hexagon with a height of 14 and base edges of 8. Part A, find the lateral area. Part B, find the total surface area. And part C, find the volume. Part A, find the lateral area. The lateral area are these 6 rectangles. Remember, it's all the faces that are not the bases. This is a hexagonal prism. So the 2 hexagons on the top and the bottom, they are your bases. So the 6 rectangles we have a height of 14, right? So this height here is 14 along the side. We have a base edge of 8, and it's going to be the same, right? The height's not going to change. The base edges don't change because the hexagon is regular. So the 6 rectangles, they're all 14 by 8. So 6 times 14 times 8 gives us a lateral area of 672. Part B, the total surface area. So we've already got the lateral area. We just have to find the area of the two bases. Uh, if you recall from the last unit, if you have a um, regular hexagon, you can create these central angle triangles, the central angle triangles, and they're all going to be isosceles triangles. So we draw in the apothem here, which is the height of this triangle, A for apothem. Um, the central angle of a hexagon, 360, divided by 6 central angles, we get 60 degrees at our central angle. Now, when you draw in the apothem of the hexagon, it's going to bisect that. So we have 30 degrees here. Not only that, but it's going to bisect the side of the hexagon. Well, we said the side was 8, right? So half of 8 is 4. So we have this 30, 60, 90 right triangle that is caused by half the side, that is caused by the apothem, and half of the central angle. So we know that half the side is 4. So the apothem is going to be 4 root 3. Our apothem is 4 root 3. The way we find the area of a regular hexagon, 1/2 times the apothem times the perimeter, 1/2 times the apothem, 4 root 3 times the perimeter, well, 6 times 8, 6 sides, length of 8 for each side, we got 48 for the perimeter. And then we have 2 of these, right? There's a base on the bottom, base on the top, so times 2, because there's 2 of these happening. Half of 2 is 1, so those just cancel out. 4 times 48 gives us 192, so 192 root 3, that is the area of our bases. So our total area, the total surface area, let me write SA for surface area, total surface area is equal to 672, that's the lateral area, plus the area of the bases, 192 root 3 units squared, onto the volume. So to find the volume of this figure, volume is equal to the area of the base. We just need one of the bases, not both, just one of the bases multiplied by the height. So the area of the base is 1/2 times the apothem multiplied by the perimeter. We don't have to multiply by 2. So you can just say it's half of 192 root 3, which is 96 root 3. Half of 4 is 2. 2 times 48 is 96. So 96 root 3, that is the area of the base. The height was given to us, I believe, it is 14. So the area of the base is 96 root 3 multiplied by our height of 14, and we get 1,344 root 3 units cubed for the volume of our hexagonal prism. All right, thank you very much. Good luck on your assignment today.